Okay, this is a lesson on solving multi-step equations. And if you paid attention to the lesson right before this, the solving two-step equations, this lesson should be pretty easy for you if you got that down. So just like before, remember that algebra problems, I like to consider them scales. So I like to put a line right down the middle of the problem because this represents the two sides of the scale. This weighs the same as this. So that's the first thing in algebra. I like to say it's a scale. Whatever you do to one side, you have to do to the other. And then the second thing is you want to get your variables on one side of the scale and your numbers on the other. And then all you do is you spend the rest of your life in algebra just figuring out all the ways to do that. So let's do this problem first. Draw your line straight down the middle. Chunk the problem just like before. And then remember, what we're trying to do is get the x's by themselves. So I got to get rid of any chunk that's keeping my x from being by itself, which would be that 1. What is that 1? It's a positive 1. If I add to that positive 1 a negative 1, and I add a negative 1 to the other side, it keeps balance, but something magical happens. A positive 1 plus a negative 1. Remember, don't think of this as 1 minus 1. Think of this as a positive 1 plus a negative 1. A positive 1 plus a negative 1 makes 0. You're left with 3x. On the other side, you're left with a negative 8 plus a negative 1 is a negative 9. Then from here, if you want to figure out what could I multiply a negative 3 by, or what could I do to a negative 3 that's being multiplied by x to get rid of it? Well, if I divide both sides by negative 3, negative 3 divided by negative 3 makes 1, so you're left with x. X equals whatever negative 9 divided by a negative 3 is, which is 3. And then you would check it. So the way you check, once again, write check. Write down the equation. 1 minus 3x is equal to negative 8. Put the number in, a 3, so we get 1 minus 3 times 3 should equal 8. 1 minus 3 times 3 is 9, should equal 8. And you could chunk this if you wanted, so you have a 1 and a negative 9 being added. A 1 plus a negative 9 is a negative 8, so negative 8 equals negative 8. Drop my negatives there. So it does work. So let's see another one. Just like before, chunk it. Then bring your scale, make a scale, a line straight down the middle. I'm going to make it a little bit smaller for myself this time. Put a line right down the middle. That represents the two sides of the scale. So, this problem's a little bit harder. I want to bring my numbers together, and what makes this problem a little bit harder is that I have numbers on both sides, but I also have variables on both sides. All right? I would typically like to bring the variables together first. Okay? So I could get rid of this positive c by adding a negative c, or I could get rid of this positive 4c by adding a negative 4c. What you need to do is figure out what's the smarter move. They're both going to work. I can add a negative c to both sides, or I could add a negative 4c to both sides. I will get the same answer when I'm done. But I like trying to have positive variables left over, not negative variables. So I'm going to add a negative c to both sides. So if I add a negative c to this side, I have to add a negative c to this side. Right? I still have 20 over here. And now I have 20 equals 4c plus a negative 1c is 3c. And I still have the minus 7. Rechunk. Now my c's are on this side of the scale this time, which is totally fine. It doesn't make a difference at all which side the variable's on. But I do want to get rid of this negative 7 now. What's the opposite of a positive 7? A negative what's the opposite of a negative 7? A positive 7. So add positive 7 to that side, add a positive 7 to this side. Finish it up. 12 plus a negative 12 plus 7 12. 20 plus 7 is 27 equals a negative 7 plus a positive 7 makes 0, so you're just left with the 3c. And then just like before, divide both sides by 3. Because when you divide both sides by 3, 3 divided by 3 makes 1c, which is what I want. C is equal to 9. And you would check this problem just like every other problem. Write check and then fill in the blanks. 20 plus C is 9, so 20 plus 9 should equal 4 times 9. 9. Let me erase that. Will equal 4 times 9 minus 7. Well, 20 plus 9 is 29. 4 times 9 is 36. Minus 7. 36 minus 7 is 29. 29 does equal 29, so this did work. My answer is 9 equals C, or C equals 9. It's the same thing. All right, so let's do another problem. Draw your bar down the middle. Chunk it real quick. Okay. Now this time, there's a smartest move to do, which is I probably want to get rid of this negative 3m so that I can bring it over here. Because if I bring the 5m over here, then I'm going to have my numbers and my variables on the same side, and that's not a smart move. It's going to make extra work for myself. So the best move is to get rid of that negative 3m, and then I'm going to have the numbers on this side and the variables on that side, and that's good. So what's the opposite of a negative 3m? A positive 3m. So when I add a negative 3m plus a positive 3m, those make 0, but I have to add a 3m to this side. Right? What am I left with? A negative 3m plus a positive 3m makes 0. They're gone. I'm left with 24 equals 5m plus 3m is 8m. And now, once again, I have my variable on the right side, and that's not a big deal. To undo multiplication, what can I multiply 8, or what can I do to 8 to get rid of it? Well, if I divide both sides by 8, then what am I left with? 24 divided by 8 is 3 equals 8 divided by 8 is 1, so I'm left with 1m, which is m. And then you would check it just like before. You would put a 3 in for that m, put a 3 in for that m, and see if it all works. That's your answer. Let's do another one. Draw your line down the middle. Okay. Chunk it. Now, this time, when we chunk it, you may look at this problem and say, well, which variable should I get rid of first? I can get rid of numbers first if I want to, but I like to get rid of variables first. I could get rid of this negative 3k by adding 3k to both sides. I could get rid of this negative 2k by adding 2k to both sides. So what's the best move? Really, the best move is to add 3k to both sides so that when I add these, I end up with positives. But let's just do it the other way this time. Let's add 2k to both sides. Because the opposite of a negative 2k is a positive 2k. So I'm going to add 2k to both sides. Okay, so what am I left with? Well, let's see. So I'm still having the 9, right? A negative 3k plus a positive 2k is going to make sorry there. The 9 stays, and then a negative 3k plus a positive 2k makes negative k. Now, if I had brought the 3k to the other side, I would have ended up with the positive k, which actually would have been better, but I want you to see that it does work either way. So what am I left with over here? 17. Okay, rechunk it. There's my 9. There's my negative k, although that's a really bad k. And there's my 17. Now, what do I want to get rid of now? Well, that 9 is keeping my k from being by itself, so I'm going to add a negative 9 to both sides. Okay, when I do that, that makes 0. I'm left with negative k is equal to 17 plus a negative 9 is 8. And that is not my answer. I don't want to know what negative k is. I want to know what k is. So if you think about it for a minute, identity property says negative k is equal to negative 1 times k. So that's a negative 1k. The way I get rid of it is dividing both sides by negative 1. Now I could get rid of it also by multiplying by a negative 1, but that's just my personal way of doing it. Divide both sides by a negative 1. I'm left with k now, and I've got 8 divided by a negative 1, which is negative 8. It's a very hard problem for students, but hopefully that makes sense to you by the chunking. All right, next problem. First thing I'm going to do, I can't chunk until I get rid of parentheses. So I'm going to get rid of the parentheses first. So to get rid of that parenthesis, I get 2 times 3z is 6z. And 2 times negative 4, think of that as a chunk now. Okay, we're getting better at chunks, so look at this as a chunk. 2 times a negative 4 is a negative 8. And I have 5z minus 2 on the other side. Be careful with z's. Sometimes they look like 2's, and I'm pretty bad about that. All right, chunk it. Then have to make a decision. What am I going to get rid of first? Well, let's be smart this time. If I get rid of the 5z by adding a negative 5z to both sides, when I do that over here, I'll end up with a positive z. But if I add a negative 6z to both sides, I'm going to end up with a negative z. So it's better to move everything to the side with more positives. And that's a good rule to follow. I haven't mentioned it so far in this lesson because I don't want to overwhelm you yet. But the best rule to follow if you want to follow a rule is bring everything to the side with more positive variables. So which side has more positive variables? This side. So I want to get rid of those 5z's. What's the opposite of 5z? Negative 5z. Add a negative 5z to this side. 6z plus a negative 5z makes 1z, or just z, minus 8 equals negative 2, because those chunks go away, right? Rechunk. You're probably by now really starting to see how easy this really is. How do I get rid of a negative 8? Add 8 to both sides. Negative 2 plus a positive 8 makes 6. So 6 equals z, or z equals 6. I'll accept either one. Not hard at all, hopefully. All right. Next problem. Example 6. In this problem, what you're going to need to do is I would recommend getting rid of the fraction first. Okay? Distribute the 1/2. So I'm left with 3 minus 4a is equal to 1/2 of 6 is 3, so 3a minus half of 4 is 2. So I'm left with 3 minus 4a equals 3a plus 2. Go ahead and make your line. All right, chunk this. You got a 3 chunk. You got a negative 4a chunk. You've got a 3a chunk. And you've got a negative 2 chunk. So the question you need to ask yourself is, what do I want to get my variables together first, so which side should I bring my variables to? Well, let's go to that rule. Always move them, try to always move them to the side with more positive variables. Which side has more positive variables? This side. So I want to get rid of this. So how do I get rid of negative 4a? Add a positive 4a. Okay? If I add it to that side, I got to add it to the other side too. Right? That makes 0. I'm left with 3 equals 3a plus a positive 4a is 7a minus 2. Rechunk. Pretty soon here, you're not going to have to circle things. You're going to start seeing those chunks, and that's good, but not yet. What do I want to get rid of now? The negative 2. How do I get rid of negative 2? Add a positive 2. So add 2 to both sides. I'm left with 5 equals 7a. How do I get rid of 7? Divide by 7. Divide by 7. 7 divided by 7 makes 1, so I'm left with a equals 5 divided by 7 is an ugly decimal, so just leave it as 5/7. Now, real quick about fractions. If you end up with some fractions in your answers, I would not recommend you check them unless you have a calculator with you, because you're going to make more mistakes with this fraction in the check than you would with the actual algebra. So if you have fractional answers, stay away from checking from them unless you're a glutton for punishment. All right, next problem. One of my personal favorites. I've got a whole bunch of fractions here. I hate fractions, hate them, hate them, hate them. So if anytime I can get rid of fractions, that's what I'm going to do. So this is what I want you to do. When you see a bunch of fractions in a problem, I want you to look at the denominators of the fractions and say, what number could I multiply them both by? Well, 4. So I'm just going to start off and multiply both sides by 4. Now watch the magic that happens. 4 divided by 4 times 3 makes 3. Remember, tops of fractions are multiplied, bottoms of fractions are divided. 4 divided by 4 is 1, times 3 is 3. That makes 3x. 3x plus 8, not 3x plus 2. You've got to distribute that 4. So you're left with 3x plus 8 equals, distribute the 4 to this, distribute the 4 to that. 1/4 of 4 is 1, so I'm left with x plus 4 times 1 is 4. Now look how easy that problem really is now. That ugly problem became a very easy problem. So now we need to chunk it. And then we need to decide what we need to get rid of. Well, remember, try to get rid of the variables first if you can. But when you do that, try to bring your variables to the side with more positive variables. So which side has more positive variables? Well, this side has more positive variables. So I'm going to get rid of the negative x. I'm going to get rid of a positive x by adding a negative x, adding a negative x. 3x plus a negative x makes 2x plus 8 equals positive x and negative x make 0. They're gone. Equals 4. Yeah? Rechunk it. What do I want to get rid of now? The 8. The opposite of a positive 8 is a negative 8. Add a negative 8 to that side, add a negative 8 to that side. I'm left with 2x, because those make 0. 2x equals a positive 4 plus a negative 8 is negative 4. Divide both sides by 2. I'm left with x equaling negative 2. There's my answer. Really hard-looking problem actually is pretty easy. All right, for the last example here, before we get into the really hard ones, once again, I have a whole bunch of fractions. So what's the common denominator for 8, 4, and 2? Well, they all can go to 8, can't they? The LCM of 8, 4, and 2 is 8. So I'm going to start off and multiply everything by 8. Okay? Now watch what happens when I multiply everything by 8. It makes a hard problem much easier. So 8 divided by 8 is 1, times 3 is 3, so I'm left with 3 minus 8 divided by 4 is 2, and 2 times the 1 is 2. So this is 2x equals 8 times a half is 4x, and then 8 divided by 4 times 3 is 6, so minus 6. Now look how much easier that problem is now. Just by quickly multiplying everything by the common denominator, I make that problem much easier. All right, so let's check it now. Not check it, let's chunk it. Well, we will check it, but not yet. Chunk the problem. What variable do I want to get rid of first? Well, I probably want to get rid of the negative 2x because I have more positives over here. So add 2x to both sides. Okay. I still have 3 over here. Negative 2x plus positive 2x, they make 0, they're gone. 4x plus a positive 2x is 6x plus 6. All right? Rechunk it. What do I want to get rid of now? A positive 6. Add a negative 6 to both sides. 3 plus a negative 6 is a negative 3. Equals 6x. Divide both sides by 6. And I'm left with negative 1/2 equals x. And there's my answer. Got it? Not so bad. All right. The last problem before we get into the special cases. And these problems right here I have a bunch of decimals. And if you hate decimals, I don't hate decimals, just fractions, but I do hate them. So anytime I can get rid of decimals, I'm going to do that. So what I'm going to do is think about this real quick. What number could I multiply all those decimals by to make them go away? Well, if I multiplied everything by 10, then when I did that, 10 times 6.8 is 68, plus 10 times 5.4 is 54, equals 4.6 times 10 is 46, plus 10 times 2.8 is 28. Decimals are gone. Then you would just solve it like every other problem that we've done. So, chunk this. What am I going to get rid of? The 46, because I have more positives over here. So add negative 46 to both, negative 46x to both sides. 54x plus a negative 46x is 8x. So I have 68 plus 8x equals 28. Get rid of the 68 by adding a negative 68. You would rechunk this, but I'm running out of room here. Those make 0. I'm left with 8x equaling negative 28 minus 68, or negative 28 plus a negative 68 is negative 40. Divide both sides by 8. And I get x equaling negative 5. Not so bad. Never had to deal with decimals. So let's summarize before I go on to the special cases. If you have a bunch of fractions, multiply by the common denominator. If you have a bunch of decimals, multiply by 10 or 100, whatever you need to multiply by to get rid of the decimals. Okay? All right. Now let's go to the special cases. There are some times when you're solving these types of problems, they're not going to have an answer. For example, let me go off to the side here. If I say 2x plus 1 is equal to 2x, there is no number that exists that will make this true. Because what's going to happen? I'm going to take some number, double it, and then add 1. And then I'm going to double that number, and somehow they're equal. That's impossible. Any number that I multiply by 2, if I add 1 to it, they're no longer going to be equal. This problem's impossible. You can't solve it. All right? So that's one type of problem. And then there's other types where, for example, if I said 2x equals 2x, well, what number works? Well, any number I want to put in here works. If I put a 1 in, 2 times 1 is 2, and 2 times 1 is 2. 2 equals 2. If I put a 3 in, 2 times 3 is 6, 2 times 3 is 6. They're equal. So all numbers work here. It doesn't matter what I try because they're equal. Okay? So let's try a couple of these. We have 3 special cases. If x equals a number, then I have one answer, and it's 0. Okay? If I end up with 3 equaling 3, is 3 equal to 3? Yes, it's true. It's going to be all numbers. And if you get 2 numbers not equal to each other, it's going to be false, and it's going to have no solution. Now, that's probably not going to make sense yet, but let's just do a couple problems. Let's start off by distributing the 3. You end up with 3x plus 4 equaling 3x. I'm not going to chunk anymore. I'm going to try to see if you can start seeing this without me circling everything, okay? Let's bring our x's together. Well, I'm going to bring those x's to this side, although you could do it either way. I'm going to add negative 3x to this side. I'm going to add negative 3x to this side. 3x plus a negative 3x makes 0. 3x plus a negative 3x makes 0 plus 4. I end up with something special just happened here. I ended up with my variables went away, and I ended up with 0 equaling 4. Does 0 equal 4? This is false, isn't it? 0 does not equal 4, so this has no solution. If your variables go away and the 2 numbers that are left do not equal each other, it has no solution. You can't check it. There is no number that you can put in there to make it work. Okay? Second example, or example 12. Distribute my 2 first. I get 2x plus 10 equals 2x plus 10. Well, right off the bat, these are equal to each other, so something special is going to happen. Let's get rid of the 2x first by adding a negative 2x to both sides. And I end up with 10 equaling, that makes 0, that makes 0. I have 10 equals 10. Does 10 equal 10? Yes, they're equal. So this is true. So when you get a number equaling a number that it's equal to, so 3 equaling 3, that's true, and so the answer is all numbers. What all numbers means is no matter what number I put into this equation, it's going to work. And you could test these, you could check them, put in any number at all, and it's going to be equal. So there's that. All right, the third type of problem. Right here we have 7w plus 1 equals 8w plus 1. So let's get rid of the 7w because I have more positives over here. So 7w, add a 7w, negative 7w to both sides, add a negative 7w to this side. That makes 0. I'm left with 1 equaling 8w plus negative 7w is w plus 1. Then subtract 1 from both sides, or add a negative 1 to both sides. I'm left with w equaling 1 plus a negative 1 makes 0. Now some people will look at this and say that's no solution. It does have a solution. This is not no solution. There is a number that works, but the number that works is 0. In fact, you can test this one. The variables did not go away. Notice the variable is still there. In these other two examples, the variable went away here, the variable went away there. In this example, the variable did not go away, so it does have an answer, and it's 0. And you can test it real quick. 7 times 0 plus 1 should equal 8 times 0 plus 1. Well, 7 times 0 plus 1 is 1. 8 times 0 plus 1 is 1. See, it works. The answer is w equals 0. And there you have it, 13 examples of how to solve multi-step equations, including special cases. Now we're going to be studying these in my class for probably a week, so we would probably do a couple of these examples each day in class. So it's going to take a few days to get good at this, but I really do think if you are systematic with your approach by chunking and doing one step at a time, you're not going to make dumb mistakes, and it should be pretty easy for you. So have fun with this, and good luck.